Hi guys, so today we'll be solving this problem called Furthest Building You Can Reach. You are given an integer array heights representing the heights of building, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladder. While moving from building I to building I plus 1, if the current building height is greater than or equal to the next building's height, you do not need a ladder or brick. If the current building height is less than the next building height or height, you can either use one ladder or h of I plus 1 minus h of I bricks. Return the furthest building index you can reach if you use the given ladders and bricks. So in this problem, we've been given a set of resources which are bricks and ladders, and we've also been given the height of the building. Now, these height of the building are uneven. Some buildings are high, some buildings are low. But we have to use the given resources and make sure that we climb and reach to the furthest building in this given array. This array represents the height of the buildings, and bricks represent the number of bricks and ladders represent the number of ladders. So in this problem, the basic intuition that we can get is that if we need to use the ladders, the height of the building can be as high as possible. So for example, if I'm on the height of building 2 and if I want to reach to a building of height 12 or maybe a height 100, I can use a ladder. But for bricks, I need to make sure that I have sufficient amount of bricks to reach to the higher building, and that is not in the case of ladder. So from this intuition, we understand that first, that we can use ladder in the height where the difference is the greatest, and otherwise we use bricks. Alright, so these are the 2 points that will help us solve the problem. That we need to use ladder when the difference in the height is the greatest, and otherwise we use the bricks. Now, how do we get to know which is the difference height which is the greatest in this heights array? So for that, we'll be using a min heap, okay, to store the heights, the difference in heights that is required for the ladder. So for example, what we'll be doing is that we'll be assuming in this array 4, 2, 7, 6, 9, 14, 12, we'll be assuming that the first difference in height, for example here 4 minus 2 is minus 2, okay, let me just write it down again. 4, 2, 7, 6, 9, 14, 12. So here 2 minus 4, I plus 1 minus I, height of I plus 1 minus I is equal to minus 2 here, right? So we wouldn't be considering that here, but if we assume that the first height which is greater than 0, we'll be assuming, so say suppose 7 minus 2 is 5, so we assume that this is the place where we use the ladder. Alright, we assume that this is the place where we use the ladder, and other places for traveling to other, jumping to other buildings, we use the bricks. But what we'll do is that we'll maintain this height in a priority queue, say pre-queue, and there we'll be checking if the jump height is greater than the pq.top. So we'll be using min heap, where min heap will be storing the minimum element at the top. So in this way, we need to find the minimum if the jump height of the current element and the next element is greater than greater than the difference in height that we assumed in the priority queue, if it's greater, then we update the jump height and we use the assumed difference as the bricks. We use bricks there, so there we would be using bricks. So basic intuition is that first we check if jump height is greater than 0, then we check jump height is greater than pq dot top. If it is, then we just you know just decrease, 1 minute, let me just write it again. So we decrease bricks from the pq dot top, which is the one that we assumed, and otherwise, and after that we'll be basically popping from the priority queue and pushing the jump height. All right, this is the thing that we need to do when jump height is greater than pq dot top. If it is not, then we simply use bricks to decrease the jump height, bricks in order to consider that building. Alright, this is the basic intuition to solve this problem. So let's code it and it will be more clear for you to understand. So guys, let's code this part. So first we can create a variable index I is equal to 0, and we can create a priority queue as I told you that we'll be using min heap. So a priority queue, in C++, the priority queue is usually max heap, or in Java when you use it is a min heap by default. But therefore in basically in C++ you need to write a comparator too. So you call it getter int and you initialize it as pq, and then we would also need jump height. Let's initialize it to 0 to store the difference between the buildings that we'd be getting. Now let's store one more variable, n, for the heights dot size. Now let's iterate through and find that while I is less than n minus 1 and pq dot size is less than ladders, till that time we'll be finding jump height is equal to heights of I plus 1 minus heights of I. So if jump height is greater than 0, we simply push it into the priority queue, which is jump height. Alright, we push it into the priority queue and we increase the I variable. So this is the part where we are assuming that, say, that first building where we traverse, where the height is greater than the current building, we use the ladder there. And we come to other indexes, then we iterate there. And we find that first we find the jump height is equal to height of I plus 1 minus heights of I. Okay, is this heights? Yeah, heights. So then, as usual, as I said, those 3 steps that we need to do here. First, we need to check if jump height is greater than 0. So we do something, we do those 2 steps. Otherwise, we don't, we know that the current height is greater than the next height. So we don't need to, use any of the resources, neither of the bricks, neither the ladders. So here we do check that if pq dot empty is not true and uh, jump height is greater than pq dot top. Okay, so the time where jump height is greater than pq dot top, we know that this is the place where we need to use the ladder. So for that we simply first we decrease bricks is equal to bricks minus pq dot top, then we pop that element, that height from the uh, priority queue, and we push jump height. All right, and now otherwise, if jump height is smaller than the pq dot top, so we know that we don't have any option, we need to use the bricks. So we do that here, and then uh, we just simply increase the index, and then we also need to keep a check that if bricks is less than 0, at that time we return I. So we know that when the resources are all empty, we need to return I. So yeah, that I think would cover all the cases. Let's run the code to see if it is working fine. Yeah, that works, and that is accepted. So I hope you guys understood the problem today. Do solve it. It's a very interesting problem, and yeah, I hope you guys understood it. Thank you.